Alright, we're going to look at solving pseudo quadratic equations. So what I mean by that is they fit the pattern of a quadratic, but they're not technically a quadratic. So the pattern would be x, or some coefficient, and then your variable to some exponent, 2n power, plus coefficient, your variable to an exponent. So this first exponent is twice as big as this middle exponent, plus a constant. So it looks like that. And a lot of times what we'll do is we'll do what we call a change of variable. We'll create a new variable. So instead of using x to the n, we'll use, say, something like u, and we'll say that's the same as x to the n. Therefore, u squared would be this squared, so x to the 2n. So your pseudo quadratic equation suddenly looks like a number u squared plus bu plus c equals 0, and now it does look like a quadratic. So what we're talking about is, let's say we had x to the 4th minus 10 x squared plus 1, and I said, okay, well, let's let u be the middle here. So let's let u be x squared. So u squared would be x squared squared, or x to the 4th. So I could rewrite this equation as u to the 4th, not u to the 4th, u squared, I meant, try to make it a quadratic, u squared minus 10u plus 1 equals 0. And then I could solve that in whatever fashion I wanted to. Quadratic formula, factoring, completing the square, what have you. And then I'd have to convert it back to x's. And we'll see how to do that. But let's just do a few more of these. Let's say we have x to the 6th plus 9x to the 3rd plus 8 equals 0. So again, I can say u is this middle variable expression, x cubed. So u squared would be x cubed squared. So x to the 6th. So u squared plus 9u plus 8 equals 0. This also works for, say, a fractional exponent. Let's say we have x to the 2/3 minus 5x to the 1/3 plus 6 equals 0. So u we would set as this middle one, x to the 1/3. So u squared would be double that, or square that, so double the power, so x to the 2/3. So this becomes u squared minus 5u plus 6 equals 0. Probably the trickiest one might be with fractional exponents, might be something more along the lines of x plus 2x to the 1/2 minus 3 equals 0. So u would be x to the 1/2. U squared, if you multiply, you square this, you multiply the exponents, 1/2 of 2 is 1, so this would be x. So this is actually u squared plus 2u minus 3. So sometimes that throws people off when they're thinking, what's this first one? Is it double the middle one? Yeah, 1 is double 1/2. So, all right, so let's, now that's a way you can turn something that isn't a quadratic into a quadratic. I think it's better a lot of times not to do this. You can kind of lose some information, lose track where you're doing, but kind of think about it. So like this last one, let's say I was going to work that out, and I want to compare it to, let me just leave these as x's, or let me work with these as u's and see how, I don't really need the u, but I might want to kind of have that concept in my head. So this will factor as u plus 3, u minus 1. So u plus 3 equals 0. U minus 1 equals 0. Subtract 3. U would equal negative 3. Add 1. U would equal 1. And then what I'd want to do is switch these back to this. So x to the 1/2 equals negative 3. X to the 1/2 equals 1. But then I have to get rid of this 1/2 power. And so you need to remember that this really means the square root of x. So to get rid of a square root, you would need to square it. So we would need to square both sides. And I would get my answers, x equals 9 and 1, and then I need to check those because this is an even root. So I need to plug them in and see if they work or not. And I'll do that in a second. But let's just see if I had left these as x's, but I had this kind of thought process in my. Then what I would do is I would split. When I factored this, I could factor this, and both of these would start with x to the 1/2. And then I would just factor it the same way I did over here. So I just leave these as x's, and I just split that x evenly between those power-wise. And then I just solve it like I did here, but I'm just using these x's to kind of help me, remind me that's really what I'm solving. I'm not tempted to stop at negative 3 and 1. I'm going to go all the way and figure out what x is. All right, so negative 3, add 1. So x to the 1/2 equals 1. Trying to go too fast. Slow down. All right, and square. And again, we get 9 and 1. And then we need to check those, obviously. Put those in the original problem. 9, square root of 9 is 3 times 2 is 6. So 9 plus 6 minus 3, is that 0? No, that's not 0, so that didn't work. 1, square root of 1 is 1, so 1 times 2 is 2, 1 plus 2 is 3, minus 3, yes, that is 0, so that one works. So you still need to check things as you go. Now, this one wasn't too bad to use the u's, but let me grab an earlier problem I did, we looked at, and show you why you really want to be careful about when you use these u's and when you don't. So I want to look at, let's say I wanted to solve x to the 6 plus 9, x to the 3rd plus 8 equals 0. So if I do that whole u thing, it's looking like this. So I think, okay, I'm going to factor that. Set each of these factors equal to 0, so I'll end up with u equal to negative 8, u equal to negative 1. And then I'll go back and say, okay, this is x cubed equals negative 8, x cubed equals negative 1. So I'll just cube root those. All right. That should work. Give me negative 2 and negative 1 as answers. The problem is this is only 2 out of the 6 answers I'm looking for. These are the real solutions, but there are also non-real solutions I need to find. And so that's kind of like this u kind of gets me into a situation where I may not actually be looking for all of those. Now, let's compare that to if I kept these as x's and I factored it there. So what I'm going to do is I'm just going to factor like I did over here. The difference is, I'm going to keep these as x's. So I'm going to split these x's up evenly. So 3 x's over here, 3 x's over there, 8 and 1, just like we did before. But now I see this is the sum of cubes, and this is the sum of cubes. We talked about how to factor that. Sum of cubes, you get a binomial and a trinomial. So I'm going to get a binomial for both of these and a trinomial for both of these. What am I cubing? X. What am I cubing to get 8, 2? Same signs, that's positive 2. Square this first one. Take the first times the second, change the sign, and then square the second one. Do the same thing over here. What am I cubing? What am I cubing? Same sign, I'm adding. Square the first one. First times second, change the sign, and then square the second one. So you can see right here, we're getting negative 2. here we're getting -1. Those are the two answers we got over here. So still getting the same answer. But now we have these things to solve. Now these quadratic expressions are not going to factor. So in order to solve them, I could complete the square, or I could use a quadratic formula. I'm just going to use a quadratic formula for these and find those other answers. So -b plus or minus b squared minus 4 times a times b times c all over 2 times a. So x equals 2. That's a 4 minus 16. 2. 4 minus 16 is -12, which is 4 times 3, so 2i root 3, because of the negative, that's where the I comes from. So 1 plus or minus 2i root 3 divided by 2 is, the 2's are going to cancel out, so you're going to get I root 3. Then we're going to do the same thing over here. So here's 2 more answers. So 1, 2, 3, 4. We're expecting 6. So we'll use this one. -b plus or minus b squared minus 4 times a times c all over 2 times a. So 1 plus or minus, got 2 on the bottom. 1 minus 4, square root of -3, so I root 3. So x equals, remember with i's, we just have to split this up into 2 parts. So 1/2 plus or minus root 3 over 2 I. And there's our other 2 answers. So there's all 6 of our answers. You want to be a little careful about using those u's, that you don't allow it to make you get into a situation where you forget to find all the answers. So a lot of times, while it's nice to think of this as, something squared something, and then, it might help you factor it. Once you kind of get to that factored, I would just go ahead and let's go back to the letters. That's really the main advantage right now of using this u, is just to figure out, oh, okay, let me not get too distracted by these higher powers and just factor this like I normally would factor it. All right. Whoops.